Okay, Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Fahmi, and today my group will be presenting about the chapter volumetric analysis, and the subtopic that we had chosen is titration. Our group consists 4 members, which is Nisrin Hayati, Nur Shahinda, Fazia Suryani, and Muhammad Fahmi Amar, which is me. Okay, first of all, what is a titration? Titration is a chemical technique that determines the concentration of a substance by reacting it with a solution of a known concentration. So, how does this technique help us to calculate the concentration? By measuring the volume of the known solution required to reach a specific endpoint, the concentration of the unknown solution can be calculated. Okay, for the titration process, first of all, we need to fill the burette and the flask with the solution, and then record the initial reading of the burette. Then, for the second step, we need to turn the stopcock to start the titration and swirl flask continuously and immediately slow the titration when the indicator begins to change color. Then, for the third step, stop the flow immediately when the color of the indicator begins to change permanently for at least 30 seconds, and record the final volume delivered in the burette. Then, for the final step, repeat the titration steps until at least 2 consistent values are obtained.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shahinda binti Muhammad Razib, and I'll be presenting about the types of titration, which is a direct titration and back titration. Direct titration is a direct addition of standard titrate to the analyte in the presence of acid-base indicator until the reaction is complete and reaching the equivalent point. Back titration is a titration where the concentration of an analyte is determined by reacting it with a known amount of excess reagent. Next, for the application of back titration that we choose is the determination of calcium carbonate in toothpaste. For the introduction of the experiment, toothpaste is acting as a basic substances and mostly produced from calcium carbonate, dehydrated silica gels, hydrated aluminium oxide, and others. Toothpaste is used to test for a base in calcium carbonate. In this experiment, we used the procedure of back titration, which we added the excess amount of the standard titrant to the analysis. The molarity of acid can be defined by the method called titration. This method is the process that determines the number of a substance by reacting it substance with known amount of another.
Next, the methodology of this experiment. First of all, we need to make sure the scale was 0 to avoid any error in this experiment. Then 125 ml Erlenmeyer or Kranecker flask were put on scale, and 0.5 gram of toothpaste were weighed using spatula directly into 125 ml Erlenmeyer flask. And then we need to record the weight value, and using a 10 ml graduated cylinder, 10 ml of H2O, which is distilled water, were added to the toothpaste, and 10 ml volumetric pipette were utilized exactly 10 ml of 0.1 molar hydrochloric acid into toothpaste or water solution. Then stir bar were added, heat and stir for 5 minutes on hot plate. After heated, remove from heat and let it cool down. Then few drops of phenolphthalein indicator were added. The titrant, which is 0.1 molar of sodium hydroxide in burette, was stirred, adding, and make sure to do it slowly. And then the pH was checked after every 1 ml of titrant added. Do not remember that both initial volume and initial pH was recorded. And then next, when solution start to turn pink but return to transparent, clear after swirling, slower, which is drop-wise perhaps, were added. After end point has been reached, the final pH and final volume were recorded. Then titrant was continued added, which is an additional 4 ml of titrant. To get the best result, again check the pH after every 1 ml has been added. This experiment will repeated 2 more times, and this will give a total of 3 separate titrations. After that, the waster were disposed in large beaker provided, and please remember that do not dispose off down the drain. And then lastly, leftover of sodium hydroxide solution will leave in burette after use.
Next, for the discussion, this experiment is about using the titration method to find out for the calcium carbonate containing in the toothpaste. It is a chemical analysis process, so the heating method takes a very important role in this method. The purpose of heating was to evaporate or to remove carbon dioxide out from the solution. Moreover, the heating process also helps in increasing the rate of reaction within the solution. The increase in temperature would make the calcium carbonate and hydrochloric acid reacted between each other easier and quicker. Next, we added an acid solution, which is hydrochloric acid, to find out the amount of calcium carbonate contained in the solution. The method was that we mix hydrochloric acid with the toothpaste. The hydrochloric acid will react with the toothpaste. Some of them did and some of them did not react. Then followed by sodium hydroxide. We added sodium hydroxide, which is a basic solution, to titrate with the remaining hydrochloric acid within the toothpaste solution. After they reacted to each other, we will be able to determine an amount of calcium carbonate within the toothpaste by deducted to the amount of sodium hydroxide, which we added the equal amount of hydrochloric acid. At the time we put sodium hydroxide into the solution, we can see that the color of it will slightly change of pinkish color. This is called an endpoint, which is a very important part of the titration method. And as the flask was stirred, it will be a little tough to see it immediately because the color changed so quickly. However, another point which also related to the endpoint of this process, which is as important as the endpoint, is called an equivalent point. This was when both solutions were added in the same amount that will be shown after changing in color. For our group, the solution's color turned to pink at the pH of 7.94 as we added the indicator to the solution. In this case, we used phenolphthalein. Since we did the experiment 3 times because we tried to be accurate with the result, it would be more accurate with 3 samples rather than only 1 sample was tested. So that's why 3 replicates form. In order to obtain most accurate amount of calcium carbonate, we need to average 3 numbers together. That's all for discussion.
And finally, for the result, as you can see in the table, the initial volume is 32.52 milliliter and the final volume is 39.5 milliliter. And if we minus the final volume with the initial volume, we will get the total volume, which is 6.95 milliliter for the sample 1. And for the sample 2, we do exactly the same, which the final volume minus the initial volume, and we will get the total volume. And from the total volume, you can calculate the concentration of the substance. And same goes for sample 3.
This is all the references that we use in this video. And that's all from us. Thank you so much for watching.